Hello everyone, I will present you the study that I dedicated 18 months of my life to build a model so that we can conduct safer, more successful and more effective naval operations. Here is the outline that I am planning to follow. I will start with bottom line up front. I build a unique, scalable and expandable discrete event simulation model with 15 components. I made approximately 1.5 million runs with that model, and then I made analysis with partition trees and nominal logistic regression. Properties of escort ships, staying power of HPU, and anti-ship missile properties of enemy ships were the most effective. Because missile engagements were so effective and soft kill methods may decrease the successful engagement probabilities of enemy missiles, they are crucial. Convoy operations under various threats are among the most primary types of naval operations. Anti-air warfare is a primary concept in naval operations. Of the many threats in anti-air warfare, missiles are the most critical. In convoy operations, the protection of HPU is the main concern. Falklands War between Argentina and United Kingdom can be regarded as the latest naval war. The British lost 6 ships all due to air attacks. 2 of them were sunk by ASM attacks. High-value units are really expensive and worth billions of dollars. More important than that, imagine a battleship or an aircraft carrier and hundreds or thousands of people live in that floating castles. These were the facts that motivated me to study over these questions and problems to reach the utmost goal of identifying effective factors in success of naval convoy operations. Fifteen main components are built to create a discrete event simulation from scratch using Scikit library that is developed by Professor Arnold Bass in Java programming language. The model includes 10,000 lines of code. It covers the most important aspects of anti-air warfare. Represent sensor and weapon ranges. Anti-ship missile, surface-to-air missile, close-in weapon system, and gun are explicitly modeled. Ships may engage to each other with both ASMs and guns. They can conduct air defense with surface-to-air missile, gun rounds, and close-in weapon rounds. Position of each detected unit are detected with a distortion. Each square with colors represents a type of weapon. For instance, the orange ones are ASMs. So what is unique about that model? The guided missile movements, formation movement in discrete event simulation, layered defense policy per ship, usage of Microsoft Access database are leveraged in that model. Usage of Microsoft Access database led us to have data that is more likely to be correct than CSV files or spreadsheets, as users are prone to provide incorrect inputs. Also, realistic sensor modeling with contact components with rotated bivariate normal distribution, stochastic damage function extending stochastic salvo models, stochastic engagements with user-defined probability distributions is modeled in that simulation. Missile engagement policy analysis with any combination, for instance, how many times to shoot before look, and analysis of all those factors is possible in the AAV analysis model. Three different scenarios are built with different red and blue ship combinations. Protecting an HVU using screen ship disposition. HVU and escort ships move on predefined route to reach a specified goal. Enemy ships patrol on predefined paths and engage detected blue units and any threat they encounter. Blue units engage detected enemy units or air threats. Each scenario had 360 degrees threat axis. The AAV analysis model included 99 factors with 8 discrete and 91 continuous ones. This design had pairwise correlation of 3.56%, and this led me 5012 design points. I made 1000 runs for each design point to reach an acceptable level of standard deviation for the survival of HVU. This led me a total of approximately 1.5 million simulated naval battles. If we imagine each factor has only two levels, low and high, which is impossible for 91 continuous factors, and decide to look at all the combinations of the AAV analysis model's factors with a full factorial design, even with only one replication of each design point, the total simulation run would take 37 trillion years with the supercomputer of IBM. In contrast, the model with nearly orthogonal, nearly balanced design took only 13 hours on my PC. This difference stems from the fact that nearly orthogonal balanced design provided enough space filling with orders of magnitude less cost. For the analysis, the primary measure of effectiveness is the HVU survival as a binary outcome. Two main analyses are made. One of them was a robust analysis on the controllable factors. The other was on all factors. Partition tree methodology and nominal logistic regression are used to analyze. The models were fit on the binary outcome of HVU survival. Of all factors, including both controllable and uncontrollable variables. As seen, escort ships, SAM properties, HVU staying power, and enemy ships, ASM properties had significant effects on the outcome. These are the ROC curves which show the quality of binary classification for the HVU survival. Both models did a good job. For the analysis of controllable factors, both models showed that SAM properties and HVU staying power have significant effects. For the analysis of all factors, results of both models agreed on 7 factors. Among those 7 factors, 3 of them were related to the escort ships and HVU. 4 of them were related to enemy ships. Both analyses showed that enemy ships' ASM properties had the greatest effect on the likelihood of HVU survival. We need to keep in mind that enemy ship properties are uncontrollable. However, these results can give insights about the most vulnerable sites of the enemy. For instance, those results can guide our intelligence activities. Highlighted that for escort ship designs, we first need to focus on the specifications of surface-to-air missiles we have. In other words, if we have a limited budget for a research and development project for escort ships, whose primary purposes are anti-air warfare, we first need to develop surface-to-air missile properties. These results also stress the importance of soft kill methods such as usage of decoys and electronic warfare, which may be effective decreasing the probability of successful hit for an ASM. As a feature work, I'll brief the study that I've made in Turkish Naval Headquarters. Soft kill methods may be introduced in the study. Additional components and objects may be introduced in the AV analysis model. The model can be run with real data to gain better understanding and exact insights. And this is me after graduation. Thank you for listening to me.